Welcome to this video. My name is Rajvir, founder of Code and Compile, and in this video, I'm going to talk about Virtual PLC, how OT makes Virtual PLC easy. So if you haven't started exploring Virtual PLC, this video is going to help you a lot. So I'm going to show you step by step how to set up your Virtual PLC in the OT platform and how you can deploy that on the edge device and how you can communicate with the Modbus server via Modbus protocols. Okay, all of that in just one video. So let's first understand the evolution of the PLC. So how PLC has been evolved. So if we go back into 1960s, we didn't have a PLC. We had relay logics. All of us know what a relay is. And you know that when you don't have a PLC, if you want to make relay logic circuits, it's very complex. Because if you want to rewire the circuit, you have to add or remove the relays, rewire it again. It takes a lot of time. It's not flexible. All right. So because of that, we introduced in late 70s a PLC. This is a hardwired PLC. And if you see closely on this PLC, there's a tiny screen. And I remember back in 2004, I worked on this PLC. And in this PLC, you have to program on the device itself. So it's quite close to relay logic because this was having just ladder logic inside, which is quite closely related to relay logic. So it was quite easy to transition from relays to ladder logic. But this PLC has some limitation. It has fixed IOs, less memory. So in that, we have a third generation, which is modular PLC. These were faster. These could have multiple IOs, so you can extend your IOs. And then there were some more programming languages which were introduced to program it in a certain way. So modular PLC helped you to have more IOs. And it was the time when we have Modbus and Profibus communication as well. And then when it was not enough, we wanted more processing power. We want more connectivity to the IT. Then we switched to fourth generation, late 2000, where we have PLC which has OPC servers inside, PLC which can communicate via Ethernet, EtherCAT, Profinet, right? So they were faster, and they were also modular. And they have some possibility to connect to IT easily, all right? When this was not enough, we moved to the fifth generation, because when it's about scaling your projects, when you have multiple PLC, 100 PLC, if you want to update all of them, right? When it's about no vendor lock-in. So when it's about open environment, we switched to virtual PLCs in late 2020s and up to present. So today I'm going to talk about what is a virtual PLC, how you can create your own virtual PLC, how you can deploy that to your edge device, all of that. Okay, so let's begin with the next slide. What is a virtual PLC? Okay, there are quite misconceptions about virtual PLC, so I will just make it a bit simpler. Virtual PLC is a software-based controller that performs the same operation like a normal PLC, but on a general-purpose hardware. So hardware could be any Linux-based operating system, which has a Linux-based operating system in the hardware. You can use that, and it will allow you to have flexible deployment. You can manage that easily, and you can deploy it easily as well. So I'm going to show you how you can do that. And so there are several steps involved, and there is no certain blueprint how to deploy that using OT, but I will follow a sequence. So the step number one is you create an account on OT. This you can do it for free, right? So let's jump to an account. We'll open my browser. So here, this is OTee.io. Okay, you can go to this website. If you are doing it right now, pause the video, go to this website, and sign up for free. Okay, you can click on this button, start for free. Because I already have an account, I can just click on login. Okay, so I will just log in with my Google account, and then I am inside the platform. All right, so now I'm inside the OT platform. You can see I already have two projects. Just ignore that. I'm going to create a project from scratch. So let's go back to the slide. So first you sign up and you log into the device. And here we are going to program using structured text, which is IEC 61131-3 compliant. Okay, structured text is a high-level programming language. So we're going to use that. And then we are going to add a device to our OT platform. And we're going to install an agent in my edge device. So for the edge device, I'm using Revolution Pi, which you can see on my table. And in that, I'm going to install an agent. And then once the agent is installed, I can directly deploy my PLC program from the cloud to my edge device. Okay, let's see that now. So in this case, let's go back to my browser. Now, first thing is you can see a couple of icons here. Here you can see your projects. So these are your projects. And here you can see your devices. So you can add a device here. I'm going to do that shortly. And if you want to change the theme, you can go to white theme or black theme. And on the top right, you will see a feedback and documentation, very nicely written documentation. You can read that as well. And this is your account details. So the step number one is you go to your project, and I create a new project. Let's call it Code and Compile. And I will call it Test Project. So once you create a project, now you have an editor. And this is quite similar to if you have worked on other PLC editors. Okay, this is a very typical, and this is very clean. You don't have so many windows here to distract you. So on the left side, you have programs, configuration, and here you can see you can create an entity. I will show you that shortly. Then you can compile the program. You can have some releases. So in this platform, you can have multiple releases of your program. So if you are compiling your program, it will make one release. If you compile it again, it will make second release. So later on, if you want to roll back to the old releases, you can do that super easily. So this is one of the key features. So you go to the program 0. Inside this, you can see there are already one-line program already defined. So these are two variables which you can see over here. So you have external variables. You can create a variable group here. You have input-output variables. You have input variables, local variables, output, temporary. Okay, so you have different types of variables here. So I'm not going to teach you PLC programming here, but just showing you what is there on the platform. All right. So here you have a small logic. Variable 0 is assigning a value to variable 1. Okay, so I'm going to make a new logic. So let's say I'm going to create a small temperature level simulator. So in this case, I will just put a comment here first. Temperature. Okay, just temperature simulator is okay, not the level. So the first thing is I need to define some tags. So here you can see how easily you can define the tags. I hope my camera is not making it worse. So let me just move myself. So I'm going to create a tag. Let's call it start. And this is data type Boolean. And if I click on that, you can see there's a different data types. You can have Boolean, byte, word, integer, real, or you can have a function block if you want to work with timers, counters, set, reset, and integral function, PID function. All these functions are here. Also the data type of array is here. All right. So let's just have one tag, which is start. And I will make another tag. Let's make temperature tag, which is a real. So this is my real. And then I will make a tag alarm, which is another Boolean. And let's make another tag X heater, which is also Boolean. So what I'm going to do is when I press the start, heater will be on. And when the heater is on, temperature will rise. If heater is off, temperature will decrease. And if the temperature is more than, let's say, 80 degrees centigrade, it will raise an alarm. So very simple logic, no fancy thing here. So I will write here if, first let me just assign heater. So you can see that you already have a tag defined here as soon as I press the enter, the keyword. So it makes it programming easy, right? So my heater starts when the start is triggered. Now, if heater is true, then what I want our temperature is equivalent to our temperature plus 0.05. Just a dummy logic. And we can say else our temperature is, so I'm just saying that it will decrease. Don't forget the semicolon. And there we go. So we have one if statement. I can just make it like this. And this is increasing the temperature. I can just put a comment here if you like. And here, decreasing. Okay, this is a typo. All right, and let me just put some limits. So I can put some limits. So if our temp value is less than equivalent to 0, then our temp is equivalent to 0. And I can put else if our temperature is greater than 0.0, then our temperature is 100. Okay. So we have defined the limits, and now I can also create an alarm. If our temp is greater than 80 degrees, then X alarm should be true. Or I can just make it very simple. Xalarm is true when rtemp is greater than 80. There we go. So very simple logic. You can see it's super easy to make a structured text programming here. And because you are using some commands, it's automatically changing the colors. So it makes you, it's easy to read that your comments are colored green and the text is white and the commands are blue. All right. So it makes it pretty easy to read. So now my programming is done and I can't visualize it right now. I have to deploy that into my edge device. In this case, first I need to add a device. So before I add a device, let me just save it. Now we go to devices and we onboard a device. So let's call it RevPi because I'm using Revolution Pi. And the architecture, you can see that it supports x86-64, AMD64, ARM64, and ARM32. So most of the edge devices are ARM32 or 64. So I'm going to use 64 because this is the configuration of my edge device. And let's click Save. Once you click Save, it's automatically creating an installer, which means it's creating a piece of code for you to help installing agent in your device. Okay, so just take a couple of seconds and we have a code here. Now we have this code here. Now we have to run this code in our edge device. So, but before I want to log into my edge device. In this case, I will use a software called PuTTY, and I will bring that here. And I can just log into my device using the IP address. And let me just see, open it. There is my login. It will ask for the ID. I will put the ID, and now I need to put the password. So I'm sure you might know. There you go. Let's see if it works. I think I put the wrong password. Let me try that. All right, now I'm inside. Now, before I enter this code, before this magic happens, I want to explain you what is happening in the code, and I need to modify a little bit, okay, just for the permissions. So I will open a notepad here, and let me just copy that, and let's just paste here, okay? So here, what is happening, if you see the first command, curl -x get, so it's going to download a file from this link, okay? And this will be the name of the file. And there is an AND command, so I'll just press enter here. And then it's going to make a directory, okay? So I press enter here because this is just the AND command. And then it is going to move the file which it downloaded or extract the content of this file in this folder, okay? This is the directory which we just created. And finally, we go inside this directory using this command, and then we run a setup.sh, which will have a couple of commands to download the images from the Docker and run the container, because this is based on Docker container. Now, before you start running the command, you have to make sure you have curl installed, you have tar installed, and you have Docker and Docker Compose installed. And this is explained in our documentation. If you go to onboard a device, you will see here there are some system requirements for hosting OT at Virtual PLC. You should have Linux operating system that we have. Internet connection, I also have it in my device. Sufficient CPU and memory, I also have that. Curl and tar installed. So this you can verify if you don't know. Just type which curl. And then you have a path, which means the curl has been installed. If you don't see the path, which means curl is not installed. Similarly, you can just type similarly which tar, then you also have a path. So these two are just the confirmation that curl and tar are installed. For the Docker and Docker Compose, you can just put Docker -v. This will tell you the Docker version. This is my Docker version. And for Docker Compose, you can just type Docker Compose -v, and that's the version for Docker Compose. So make sure you have these installed. And then you have to add your own user to the Docker user group. For that, you can run this command. I've already done that. So from my, it's already done. That's it. That's all you need to set up Virtual PLC. Now what we're going to do is I go back to this command. And now because my edge device needs some permission, so I have to add here sudo curl. And for making a directory, I also need a permission, sudo make directory. For the tar, I also need a permission. I believe if not, that's totally fine. And for going to the directory, I don't need a permission. And for running setup, I also need permission. So I just put sudo behind these commands. I will just copy that now and paste here, and let's see if the magic happens. There you go. I pressed enter, and now it should start downloading, and it will start downloading only if you have internet connection. You can see that now it's downloading the file. This is the tar file, and now it's doing extracting the file, going to the folder. Now it's loading the images from the Docker. You can see that images are being loaded. It's creating some containers, and it should shortly start my containers and start my agent. So just stay tuned and just wait for a few seconds. Let the virtual PLC do its own thing, and then in the end, we'll be able to run the command. So I'll just wait a few seconds and see how it goes. All right, now seems like everything is working fine. I just need to confirm now if the Docker containers are running. In this case, you can just, let me just clear this window. Just type docker ps, and then you will see there are some containers running. Let me just make it maximize. We have 3 containers running. OTE runtime, you have to make sure this one is running. NATS is running, it's important for the communication, for publishing and subscription of data. And OT agent. So we have 3 containers which are running, and this is important if you want to troubleshoot your virtual PLC. And now we go back to our OT and click on done, and let's go back to, or you can save it as well. Let's go back to projects and open our first project, code and compile. Go to the program, and now you just have to deploy it. Okay, so we have already installed the agent. The agent will build the communication, which means the edge device and the virtual PLC on the cloud. Okay, now we can just deploy that. In this case, you can first save the program, and here select the virtual PLC from top. So here I have this RevPi, which I just created. And now you have this button highlighted. You can download this project. You have 3 options: using current tag values. This is the tag value which is already in the edge device, but we don't have that. This is the first time we are doing it. Using initial tag value. This is the option we're going to select. Click on apply, and it is going to compile the project. And you can see the diagnostic here. There you go. So you can see that project is built successfully, it's compiled successfully, it's downloaded successfully. All right, so we have already downloaded, fraction of seconds. And now we can monitor our project. In this case, I go to display live tag value. If you click on that, you will see here tag values directly coming from your edge device. Remotely, you are able to view what is happening on your edge device, okay? And then you have a very nice feature here, which is a tag browser. In the tag browser, you can open this tree, and you are able to view your tag. You can see that it's in my resources, program 0, instance. This is my instance 0. And here you can have a temperature value, which is 0. You can also see it here. But in tag browser, you're able to modify the tags. So here, if you see I have X start, I can click on that and make it true and press enter. And this will make it true. And you can see that now the temperature should increase. Okay, it's increasing way too fast. Oh, sorry, my bad. It should be 100 here. And I was wondering why it's jumping so fast. But you can see that you can easily edit your program. And once your program is okay, you can download that to your device, and it will automatically create a release for you. Okay, so it's easy to troubleshoot because you have a monitoring of your PLC program. You have a tag browser to play around with the tags. So yeah, just like every PLC programmer, many people make mistakes. So this was my mistake. I found it now, and now it should be up and running. So let's see one more time. We go to tag browser. You can also monitor that here. And right now the start is false. Let's make it true. And now the temperature value should increase. Now you can see that it's increasing. Okay, now it's increasing in a natural way how it should be before. And you can visualize this value here. You can also visualize this value here. Pretty neat and clean. And if it's more than 80, you will see that the heater tag will also get true based on your logic. And you can also make it false here. So you can play around with the tag values, make it true and false. And the important part here to understand here is this is unstructured text. This is IEC 61131-3. So this is like a standard way of programming the PLC. So if you have some program written in a different PLC and you want to bring it here, you can copy paste the code. Okay, it's not that difficult. You can also import your tags here. So here you can see import variables. So you can copy paste the variables from your, let's say, codices and bring it here, and it will structure the variables for you. Okay, this is the important part. So right now it's 100. Heater is true, alarm is true. I can now make it false, bring down the temperature. Okay, so here we go. Now it's bringing that temperature down. Now the interesting part here is we can also add a Modbus communication to that. Okay, so let's just go back to the presentation now so that we are not running way behind in my presentation. So what I wanted to come here is system setup. So what we did initially, we created virtual PLC in the cloud, and then we securely deployed it into our edge device. Our edge device was Revolution Pi in this case, which was ARM64 based controller. And in this edge device, we are running Docker containers. Now the next part, what I'm going to do is I'm going to connect to a Modbus server and share the values. So here you can see the values are for this project, which I'm going to show you shortly. But in our project, let's come back to our project. Now I want to add a Modbus communication. And in this case, this virtual PLC in my edge device acts as Modbus client. And I'm going to connect to Modbus server. Okay, so Modbus server, I have created a simulated server, which is in my computer. I can show you here. This is Modbus slave. This is just a software which has an IP address and a port address. So if I disconnect that, I will connect that again. You can see that this is the IP address of my computer, and this is the port address. So it's in my computer, a Modbus server running. Okay. Now here in this Modbus server, I'm going to push the value of the temperature, okay, to show you that you can also interact with the field IOs. Most of the time when you have field IOs, those are either Modbus based or Profinet based or some communication. So I'm just going to show you the Modbus example here. So in this case, I go to my configuration. Now, first of all, just to show you other parts in configuration, you also have this task, which is my task. And this task is running an instance 0 with the program 0, which is over here. This is running at an interval of 20 milliseconds. Okay. And here you can add multiple instances. You can add multiple tasks. In case if you have some functions, function blocks, you can also add that here. And then you can also assign global variables if you want to use globally. I was working with the local variables, but you can also define global variables. Okay. So here I'm going to click on entity, and here instead of function or function block, I will click on driver configuration. Okay. In the driver configuration, I can add Modbus communication. So in the driver, you can see I have Modbus already there. Click on Modbus and click on save. And now I have to add a client because I'm going to connect to a server. So add a client. If you want, you can give it a name. I will just give it as default. Invocation rate, you can define the rate of invocation and delay. And now comes the remote IP address, which is my IP address of my computer. This is the Modbus which is running here. This is the IP address. And the port address by default is usually 502. That's it. That's my communication for my Modbus. And because I put my computer, because my computer is able to access this edge device, so you have to make sure those are in the same network. Okay. So now add request. Now what I want to do, I want to write the value. Okay, so let's say I write here, write request. I want to write a single register over here. Slave ID is 1, timeout is okay. By default, I put number of channels is 1, start address 0. That's totally fine. So you can see that this table is automatically populated. So smart. If I put here 4, you can see the 4 addresses and 4 symbols. So it makes it very easy. I will just put 1 here because I just need to put 1 value. I can give the name temperature in integer. Okay, that's it. That's my Modbus configuration. Coming back to the program, and now I want to send my temperature value to the Modbus. In this case, I have my temperature value in real. I need to convert that. Don't worry. This editor will help you to convert that super easily. So in this case, I have to type now, first I need to declare a variable, add a variable iTemp. You can use any name that you like, and I make it integer. So I hope you can see it because of my camera. iTemperature, right? Now I will say iTemperature is equivalent to, just put real, and then you will see all of the conversions here, real to int, and you can type here rtemp. Or I think you can also put semicolon, rtemp. Let me just write it like this, which is super easy for me. Okay, so now I have converted my real to integer. Now it's going to rtemp, but this is still, itemp. This is still a local variable. I need to map this to my Modbus variable. This is very easy here. All you have to do is go to your variable and click on this dash line and select the variable that you just defined, which was itemp. Just click on that. Now it's mapped. Super easy, right? Now let's just download this project. And I have to make sure this is okay. And let's bring this here and let's see if it works. You can also go to live values. So it's still deploying. And if you have any errors, you can see that here. Now it's downloaded successful, no errors. And let's see, right now this is 0, temperature is 0. I'm going to start my heater. There you go. You can see now the values are coming. So I'm able to communicate via Modbus to a Modbus server. Okay, super easy, simple steps. So now what I'm going to do is I'm going to show you a small project which I created before. It takes some more time to create the project, but I'm going to show you this project where you can communicate in Boolean, in integer. You can convert some arrays to Boolean and things like that. I'm doing in one of the projects I'm going to show you shortly now. So we can just turn this off and go to our projects. Let's save it with Simumatik. So it's a bit complicated project. It's just how I'm assigning the Modbus inputs to Boolean addresses and then doing the logic and converting that Boolean back to the integer. So this is what's happening in this project, okay? But I'm just going to show you the possibility what you can do if you have a Modbus IOs. So here, this is my project where I have Modbus-based IOs. Let's understand it this way. So I'm going to start this emulation. And here, I'm going to deploy that project. So here, first I have to select Virtual PLC and click on Deploy. So this will overwrite the Virtual PLC project that I had before, okay, by deploying this now. So I hope I have no errors because I was using it before. And let's just bring it like this and bring it like this. So basically, I'm still using my Modbus server from Modbus slave, and these both are clients which are communicating. Okay, so now let's see if I can I can't organize the window, but let's see if the project is working. I can maybe move it like this. So this we can monitor. Everything is false. If I press this one, oh, this is going up. Okay, so this project, the PLC program for this system is working in my virtual PLC, where I'm able to move this pallet up and down. So you can see when I press this one, it goes down. And based on the sensor signal, I have an indication if it is completely down or if it is completely up. And you can see the feedback of this pallet, it's coming. If I show you now the tag browser, here in the tags configuration, this is the feedback. This is the feedback 32767. It's basically 10 volts when it's completely up. And if I bring it down, you can see this will change based on the value. Okay, based on the scan time, it's updating the values. So this was how you can use Virtual PLC to control anything you like. It's just like a normal PLC. The step is just you have to first create a project on the OT. You have to update your edge device with a runtime, install these images and run the Docker containers, and then your edge device is ready. This is just one-time step. Then you can log in from anywhere, create the project, and download to your edge device and start monitoring it. You can also just do that with your mobile phone. Just log in your mobile phone. Actually, I was trying that before, and I was able to visualize my OT values just by logging to my project. I think I don't have it right. Oh, here you can see that. So you can log in with your phone as well, and you can monitor the values because it's browser-based. You can also write a program in your phone. It's not an ideal situation, but you can use a tablet, your phone, or any device which supports browser. You can use that for creating your projects and deploying it to your edge device. How easy it is. There is no vendor log. You don't have to have any software installation. Just do it from your browser. This brings us to the next slide, which talks about the features. So let's see the key features of Virtual PLC from OT. Number one, centralized, secure cloud environment. So it's a centralized environment. You do everything from one location. So you have one account and you can control everything from there. With the role-based access, so you can define different access to the user. If the user is allowed to program the PLC or just allowed to view the PLC or allowed to add some Modbus connection and so on. So you can define different roles. Industrial grade, open runtime environment. So industrial grade means the runtime can adopt itself based on the hardware, if it's 32-bit or 64-bit architecture. And it also defines that it will work as a real PLC. If you have a scan time of 20 milliseconds, it will work exactly in that time. So it's industrial grade. Hardware agnostic, it's not hardware based. It's not a vendor lock-in. You can use any hardware with Linux operating system. And the programming platform is IC 61131. This is a standard programming platform. So if you have different PLCs that you want to adopt with Virtual PLC, you can use the programming code of the other PLC and bring it here if it's instructor text, okay, because it's the same standard of programming. Fleet management and zero trust security. Fleet management means you have one account from where you can manage all your virtual PLCs. Doesn't matter where they are located because they are connected by the agent to your account. So you can control the instances, you can control the versions, you can stop the instances, you can change the program, update the PLCs, add Modbus communication. You can do everything from one location, making you very flexible way to manage your virtual PLC. Zero trust security means it does not trust unless it's verified. You have to verify all the accounts, all the transactions that you are doing with the PLC. It will not trust you otherwise unless you are authorized user. Next one is support for protocols. Like we just saw how it can work with Modbus TCP. It also supports Ethernet IP. And not only these two, there are multiple communication protocols which are in development. So just to show you the development phase, right now they're working on AI for code generation. So in the future, if you want your code to be generated automatically, you can just put a prompt and you have a code there, or it can check your code as well if it's right or wrong. Integrated CI/CD pipelines. So your code can be tested and can be deployed without any errors. It will be checked first before it gets deployed. And if you have a lot of instances running, it will help you in deployment really easily. And then you have community-driven libraries, version controls. We have seen that. Industrial communication protocol like Profinet, EtherCAT, and BACnet. They are in development phase. And if you want to impact their development phase, if you have some ideas that you want OT to implement, you can scan this QR code, go to the Discord community, and put some queries and talk to the developers. Okay, this will help you to bring your ideas. Maybe they like it, and maybe they want to implement what you want. Because when you're in the development phase, you need a lot of ideas and feedback. So feel free to join the Discord community and be the part of community. All right, so thank you for watching this video. I hope you like Virtual PLC from OTee. I hope you get the idea of how Virtual PLC works and how you can also implement your project in the Virtual PLC on the OTee platform. So all you have to do is start for free. Go to the OTee.io and sign up. You get a free access right now and start playing around with your Virtual PLC. And if you have some interesting things to share, feel free to post me on LinkedIn or write me an email or just put a comment on the YouTube video. All right. So thank you for watching, and I hope to see you soon in the next video where I will maybe explore more about OT and bring you some more interesting examples. So thank you for watching. See you the next time. Bye-bye.